Hey everyone, in the next two lessons we're going to be talking about radical expressions. So what a radical expression is it's an expression that uses a symbol called a radical. In this lesson we're specifically going to talk about square root. So if you see this symbol, that means square root, or if you see this, that also means square root. This symbol technically means the root of. Now we're going to need, and that's called a radical. We're going to need some vocabulary words in order to get through this lesson. So the first vocab word that I'm going to talk about is radicand. Now, the radicand is the expression you're finding the root of. So, if I had something like this number here would be called the radicand. It doesn't always have to be a number, it could also be a variable with it. So this would be the radicand. That's what we're trying to find the root of. And then we have the index. The index is this little number here that's in this little hook. If there is no number in the little hook, like in the first one here, then there technically is an imaginary 2. When we are doing radical expressions, you will never have a hook with an index of 0 or 1. So if there is no index, like you see in numbers 1 through 3, if there is no index, then technically there's a little imaginary 2 there, and that means square root. So if you see a radical with a little 3 in there, that would mean cubed root. If you see a radical with a little 4, that would mean fourth root. You see a radical with a little 5 in there, that would mean fifth root, and so forth. We are going to be dealing with square root in this lesson only, and then we will move on to cubed root in the next lesson. So for right now, we're just dealing with square root. All right. Radical expressions have to do something with exponents. So we talked about exponents. For example, if I gave you 3 squared, that's the same thing as 3 times 3. Which is the same thing as 9. All right. Well, going kind of backwards, if I asked you for the square root of 9, that can be broken up into the square root of 3 times 3. And here's the confusing bit. Square root means we're trying to find a pair of numbers that are identical. Like here I have 3 times 3. That's a pair of numbers that are identical, and we only take 1 out of the square root. So we don't wind up with 3 squared as our result of the square root of 9. We wind up with just 3 as the square root of 9. Now I'm going to make it easier on you guys, and I'm going to give you a little cheat sheet when we complete these problems that you can use on your test. And it is located on the way back of your notes packet. If you want, you can tear this sheet off and have it next to you while we're using our notes today and while you're doing practice, because that might help you. This is a table of the perfect squares, cubes, fourths, and fifths. I'm not going to give you the 6th root of anything, but I may eventually give you the 4th root and the 5th root of something, so you will need maybe these last 2 columns. For this lesson only, we're going to be focusing on the x squared column. So all of these numbers down here, down in that column. And then now on this chart, you actually do not need to focus on this first row of 1s, because every number is divisible by 1, so this row isn't going to help you very much. So we're going to be focusing on this second row, or second column here, starting with the number 4. And we're going to get started. So if I'm doing the square root of something like I am in number 1, I want to split the number 32 up into 2 factors. So you can think of some factors of 32 right now. There's many factors of 32, 8 and 4, 16 and 2, and so forth, 1 and 32. But we want to specifically find the largest perfect square factor of 32. So how we're going to do that is we're going to use this chart. All right, and we want the square root of 32. So the radicand of 32 is the number that we're focusing on. And what we're going to do is we're going to go down the x squared column, and we're going to find the largest perfect square factor of 32. So in my calculator, I'm going to start with 4. I'm going to do 32 divided by 4. And it works out nicely. We get a 4 times an 8. So what that means is that 4 is a perfect square factor of 32, but I'm not necessarily sure if it's the largest one. So let's keep going. Now let's go to the number 9. In your calculator, do 32 divided by 9. Now it comes out to be a decimal, and that's not good. That means that 9 is not a perfect square factor of 32. Let's keep going to the next number, 32 divided by 16. That actually did work out for us. We get a 16 times a 2, which means that 16 is a perfect square factor of 32, and 16 is larger than 4. That means 4 will not be the perfect square factor that we will use to simplify this radical. We want to use the largest perfect square factor. Let's move on to the next number, 25. 32 divided by 25 comes out to be a decimal. So that means that 25 is not a perfect square factor of 32. And then now if we look at the rest of the numbers in this column, all the rest of the numbers are larger than 32. So none of those are going to be perfect square factors of 32 since they're larger than 32. So we can stop. All right. And we're going to stop, and 16 was the largest perfect square factor of 32. And we could split 32 up into 16 times 2, because 32 divided by 16 was 2. And if I do 16 times 2 in my calculator, it is equivalent to 32. So I didn't change the value of my radical expression. I just changed the way that it looked. I changed I split it up into 2 factors. Okay. Now, which one of these factors is my perfect square? 16 was my perfect square because that's the one that fell on the chart. And if I do the square root of 16, that comes out to be, if I look to the left, that comes out to be 4. So what I'm going to do is I'm actually going to do the square root of 16, and that means 16 is going to disappear from under my radical, and I'm going to pull a 4 out because square root of 16 is 4. And then 2 is left underneath my radical. 2 is not a perfect square, and 2 does not have any perfect square factors, so we can't do anything with that 2. In fact, if you do the square root of 2 in your calculator, it comes out to be a very long decimal, and I don't want you to do that because we're not going to round, we want to be exact. So 4 root 2 would be your final answer. So I'm going to show you again on here, on your notes. So we split 32 up into the perfect square factor of 16 times the non-perfect square factor of 2. We then did the square root of 16 because it's a perfect square. The square root of 16 is a 4, and we took that 4 out. The square root of 2 is not a perfect square, so that remains underneath your radical. Now, please do not write that 4 as your index. I do have a lot of students do this, where they write the 4 as the index. That's not your index. Remember, the index is still technically an imaginary 2 here. If you want to write the 2 in your index, that's completely fine, but not necessary. 4 root 2 is your answer. We're now going to move on to the square root of 72. So that means we start over from the beginning on my table here. And I'm going to still look at the x squared column because I'm still doing square root. I'm not going to look at the first row. I'm going to start with the number 4. So in my calculator, I'm going to do 72 divided by 4, and that does work out. It becomes a 4 times an 18. Next, I'm going to do 72 divided by 9, and that also works out. That's a 9 times an 8. Now that means that we can cross off the 4 because we found a larger perfect square, but we do need to still keep going. Now I'm going to do a 72 divided by a 16. That comes out to be a decimal, so that's not a perfect square factor. 72 divided by 25 also comes out to be a decimal. That's not a perfect square factor. 72 divided by 36, that does work out. 36 times 2 is equivalent to 72. So that means 36 is a larger perfect square factor than 9, so we can cross off 9, and then we keep going. 72 divided by 49 does not work out, that's a decimal. 72 divided by 64 comes out to be a decimal, and then the rest of the numbers are larger than 72. So the perfect square factor we are using is 36, and a 36 times a 2 is equivalent to 72. From the chart, the square root of 36, if you look all the way over to the right, the square root of 36 is a 6. So I can cross off my 36 and pull a 6 out. And then the square root of 2 cannot be done, so it does remain underneath my radical. Square root of 2, 2 is not a perfect square. It does not have any other perfect square factors. Now we're going to move on to number 3, which is the square root of 12. So we start over from my chart, x squared column. So 12 divided by 4 is a 3, it works out. 12 divided by a 9 gives you a decimal, and then all the rest of the numbers are larger than 12. So 4 is your largest perfect square here, and a 4 times a 3 is equivalent to 12, so I'm going to split up number 12 into a 4 times a 3. The square root of 4 is a 2, so I'm going to take that 2 out and cross off the 4 because I did something with that. I took care of that. And the square root of 3, 3 is not a perfect square. It does not have any perfect square factors, so it just remains as the square root of 3. Number 16. This is the same thing as the denominator of this fractional exponent is your index, the 16 is your radicand, and the 1 is the exponent attached to your radicand. So essentially this is just the square root of 16, so we can just write it like this. And if we look at our list here, 16 is already a perfect square. So we don't need to split it up into anything. The square root of 16 is 4. So your answer is just 4, or number 4. All right, the next problem here is the same thing as the denominator of your fraction is your index, and 25 to the 3rd power. Now this can be rewritten as the square root of 25 times 25 times 25. If we look on our chart, 25 is a perfect square. The square root of this 25 would be a 5. The square root of this 25 would be a 5. The square root of this 25 would be a 5, which leaves me with nothing underneath my square root. I just have a 5 times a 5 times a 5, which is a 125. That is my answer. So in numbers 26, we really have the square root of 32 to the 3rd power, which is the same thing as the square root of 32 times 32 times 32. I'm going to show you a different way to do this. Now, square root means we're trying to find a pair of identical numbers. Well, here's a pair of identical numbers here. So we can take one of those pairs out completely, and now I'm left with 32 times the square root of 32. If we look at number 1, this 32 could be split up into a 16 times a 2. So that's what I'm going to do here. I'm going to split this up into a 16 times a 2. And then now the square root of 16 is a 4. When I pull that 4 out, I multiply it by the 32 that's already on the outside, and the square root of 2 cannot be done. I'm going to have you try 7 and 8 by doing the same thing of when you pull something out, you multiply it by the number that's outside. And here are your two answers. You pull a 4 out of number 7 and